Good day, everyone, and welcome to the part one of our lesson on functions. So, basically, this part will just give a quick review on all the things that we have learned on functions when you were in your junior high school years, or even elementary, if you were. So, our objectives are the following. First, we have to define what is a relation and what is a function. We have to determine if a graph describes a function. How would we determine using just looking at the graph if it's a function or not? Third is we have to perform operations and functions. Fourth is we have to evaluate functions. Fifth is to describe the domain and range of a function. And we have to learn the difference between bijective, surjective, and injective. To start, let's define a relation. So, according to some sources, a relation is a set or collection of ordered pairs. An ordered pair, commonly known as a point, especially in the Cartesian coordinate plane, has two components, and these components are your x component or your x coordinate and your y coordinate. An example is this, your 5, 2, where 5 negative 2 rather, where 5 is your x coordinate and negative 2 is your y coordinate. As long as the number come in pairs, sana all, then they become a relation. And take note that relations can be represented by the following, but not limited to the following. So we have a set notation, table of values, we have mapping diagrams. Now, after defining what a relation is, we will now get to know the domain and the range of a function. So domain and range actually um can also be applied to relations. Parang nag-una siya, no? Before I defined a function, because the domain is the set of all x or input values. If we have a machine or a function machine, x is the input values, and your range is a set of all your output values or your y, or the second value in your ordered pair. Now, a function. A function is a special kind of relation because it follows an extra rule. So, like relations, the functions can also be set of ordered pairs. However, this is the extra rule. Every x value must be associated to only one value. And functions, like relations, can be a set of ordered pairs, equation, graph, or a set of table values. So here, this is an example, illustrative example. So we have the domain and the range. This is mapping. So this is a one-to-one function where your domain is mapped to exactly one range. This is a many-to-one function where there are many domains that are mapped to one range. Now, see, ABC is mapped to your range that is 2. This one is not a function. Notice, because your negative one has two outputs. It's 3 and negative 2, making it not a function because when we go back to our definition of function, it is a relation which has an extra rule, that is, every x value must be associated to only one value. Again, every x value must be associated to only one value. And for this third example here, our x value, which is negative 1, is associated to two y values, which are 3 and negative 2, making it not a function. Now, when we look at the graph, No, we can use actually a vertical line test to determine if a graph is a function or not. No. Now, if you put a vertical line to the graph of the function anywhere between on the graph of the function, and if it intersects in one and only one point, take note, one and only one point, then that graph represents a function. The vertical line test is actually known for some as the pencil test, meaning you let your pencil move and pag, there will be no two points that would intersect your pencil. That means that that graph is a function. Is this a function? Yes, it is a function. Now, bisag anywhere we draw the line, no, the vertical line, nagatouch siya to only one point. There's a function. This one, this is a quadratic function, yes. A parabola, di ba? This one is not a function. Because notice, no, we have a line here, for example, this fourth line, a third line here, touches 2 points, no, or intersects the graph into 2 points. Therefore, it is not a function. Take note of this line. All functions are relations, but not all relations can be a function. Again, let me reiterate that all functions are relations because we know that functions are special relations, but not all relations can be a function. This time, we have to differentiate, no, injective, surjective, and bijective. So first, again, this first example over here is not a function because there is the first element in A maps to two elements in B. That means, oh, 'di ba? Wala na siya nag-satisfy sa atong extra rule that would make a relation a function. But this illustration over here is a relation. It's not just a function. Next, the general function B can have many A. So si B can have many A. Yes. Injective. Injective means that B can't have many A. No? So B can't have many A. There exists one element in B na wala nagmap sa A. So that's injective. Surjective, it's not it's not injective, meaning ang tanan nimong elements, all of your elements in your B is mapped to your A. That's surjective but not injective. Next, bijective or onto. No, onto functions are both injective and surjective. Again, bijective functions are both injective and surjective. One to one and onto. So, pambalikon, injective is one to one, meaning B can't have many A. So, tagsagid sila, pare sila. And then, surjective, meaning B has some A, meaning tanang element sa imuhang B, sa imuhang range, kay nagmap di A. And if you are bijective, if it is a bijective, meaning it is an injective and it is a surjective. Now we go to operations and functions. We can actually add, subtract, multiply, and divide our functions. No? And the result is actually a new function. And we also have composite functions. This is read as f of g of x, where here, this would be represented as this one. And then g of f of x is this one. So let's have illustrative examples. Suppose we have f of x equals 2x plus 2 and your g of x is equal to x squared minus 1. And we have to perform the following operations. We'll do it one by one. We have f plus g of x is simply adding the two functions. So we have 2x plus 2 plus x squared plus 1, and then we combine like terms, giving us x squared plus 2x plus 1. Or if we wish to simplify, or if you were asked to simplify, you could have x plus 1 quantity squared. Subtraction is somehow related to addition. No? Lahi lang yun sila og sign. No, we combine like terms. Make sure lang to distribute the negative sign here. Okay? Multiplication of functions. I am certain you already know this, no? You can have the FOIL method if you are dealing with binomials. And division of functions. I believe we have already had this one in our review on algebra. Now, how about composition of functions? We have g of f of x. What will happen? This means that we would take this function here and substitute our f of x to the variable here in your g of x. Meaning, kaning 2x plus 2, mao niya itong isubstitute sa ato ang x squared. Making the equation 2x plus 2, which is your f of x, squared minus 1. Okay, mao man na itong g of x. And then when we do the math, we simplify it as 4x squared plus 8x plus 3. So, do the math na lang. Next up, we have f of x plus g of x plus h of x. Same thing. And we just combine like terms. And then we will get x squared plus 8x minus 2. How about composition? H of g of x. So, i-take na to si h of x. Nya, ang x ni h of x atong ilisan sa value ni g of x. So, that means na from x squared minus 1, ilisan na tog 3x minus 2 squared minus 1. That's it. And our next discussion or the next part of our video is about linear functions. So stay tuned.